We have two integrals here and we're trying to find a relationship between them. So I'm going to start with s. And this is the product of two functions, so it makes sense to try and use integration by parts to deal with this. What do we let equal to u and what do we let equal to v? Well, because we're trying to show that this is true, we're trying to get a 2 going on somehow. It makes sense to let this equal u, because when we differentiate it and get u dash, we're going to get a 2. I mean, that might not necessarily work, but it will in fact work. And if you go the opposite way, you won't get the required answer. So v dash is then sine x, which means v is going to be, or integrating sine x, it's going to be minus cos x. We can then use integration by parts, so it's going to be u v evaluated at these limits minus this integral. Okay, that's just a reminder of integration by parts. So for us, that's going to be e to the 2x cos x. There's a minus in there as well, don't forget that. Minus u dash is e to 2x, 2e to 2x. V, remember, is minus cos x. So in fact, we can put cos x and change this to a plus. What we can also do is actually bring this 2 outside, because when you're integrating or differentiating, the constant just sort of follows through. It's out. Treat this as a summation. You can basically do your summation and then times by 2 rather than having 2 in there all along as you're summing. That is a little thing it is something you can do anyway. I'm not going to go into any more detail than that. Now we're going to substitute in for pi over 2. So we're going to get e minus e to the pi. Then it's going to become cos pi over 2, which is the same as cos 90 in degrees, and that's actually 0. So this is going to disappear. And it's minus e to the 0 cos 0. And note, I brought the 2 out because now we can see that this is actually this c integral. So it's plus 2c. E to the 0 is just 1. Cos 0 is just 1. So we're going to get 1 plus 2c as required. Brilliant. So we have a relationship between s and c. That doesn't actually allow us to get c as it stands. Now we've tried to integrate s and got it in terms of c. So the natural thing to do now is to try and work out what c is going to be in terms of s. Hold on, let's put e to the 2x first, sorry. Okay, and let's do the same thing again. This is going to be u, and this is v dash. When you integrate cos x, you just get sine x. So I'm not going to write out the general formula again for integration by parts. I'm going to go straight into it. So it's going to become uv minus u dash v. Put the limits in. E to the pi, sine pi over 2. That's sine of 90. That's actually just 1. And then it's going to become minus e to the 0 sine 0, which is actually 0. So that term disappears. Over here, as before, I can actually bring the 2 out. So I'm going to get minus 2. And then this thing here is back to s. So what do we have? We have that s is equal to, how do we write it? 1 plus 2c. And c is equal to e to the pi minus 2s. Note actually, I just realised, if you had put these the other way around at the very start, this is u and this is v dash, you would have got this formula. So you could have still gone that way and then done the same again, just making sure you're careful. It's just you wouldn't have got to part A as quickly, but you would have got the results that you needed for B. So it would work, in fact. Right, we've got well, we kind of got simultaneous equations, but we're just asking to find S, so I can actually just replace this C here by this C here, and hence by this. So it's going to be S is equal to 1 plus 2 lots of e to the pi minus 2s. So that means that 5s is going to equal 1 plus 2e to the pi. That's the key bit, really. Get s all on one side, and we've removed c. We've got 5 lots of s, so we can see that s is going to be 1 plus 2e to the pi all over 5. What a really nice way of doing this integral. Brilliant.